Hello friends, welcome to this session in which I am discussing experiment number 8, and the experiment number 8 is related with t-test, test of equality of two population means. In the previous session we have discussed t-test for single mean. Now we are discussing the t-test for equality of two population means. See, there are two examples. In the first example, the data is given. The values of n1, n2, x bar 1, x bar 2, s1, s2 are given. But in the second example, we have given the sample values. So therefore, in the second example, we need to calculate the values of x bar, s1, x bar 2, and s2. Right? How to solve this example? See, what is the aim in this case? The aim is to test whether there is a significant difference in means of type 1 and type 2 electrical bulbs. So that is my H naught in this case is mu1 is equal to mu2. So what I am assuming here that the both population means of type 1 and type 2 electrical bulbs are same. So what is the formula? See, the formula is this one. So T is equal to x bar minus y bar divided by s upon s into root 1 upon n1 plus 1 upon n2. So which follows T with n1 plus n2 minus 2. So this value is my table T, and this value is my calculated T. And what we need to do, we need to compare this calculated T with table T, right? So where s square is given. So this is the value of s square. So what is n1? N1 is 9, n2 is 8, x bar 1 is this value. So 1134, x bar 2 is 1066, and s1 is 36, s2 is 40. So if we apply this formula, so apply the formula s square is n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. What we are getting? We are getting the value as 1630.93. So if you take square root of this comes out to be 40.38. So this value is there. So what is the procedure? The procedure is let x becomes the length of life of electrical bulb of type 1. So I am representing x as this value, length of life of electrical bulb of type 1. And what is y? Length of life of electrical bulb of type 2. What is the null hypothesis is mu1 equal to mu2. And what is the alternative hypothesis? Mu1 is greater than mu2. Because what we need to test here, see, is the difference in the mean sufficient to warrant that type 1 is superior to type 2? See, the word in this case is superior. So for superior means whether it is greater than type 2. So therefore we are using right-tailed test. See, this is the right-tailed test, and the level of significance is 0.05. So just I have by using my software I have calculated all these values, but you can calculate by using calculator also. So this is T is equal to x bar minus y bar upon s into root 1 upon n1 plus 1 upon n2 follows T with n1 plus n2 minus 2, and the level of significance in this case is alpha. So put all these values 1134, 1066, and this value we have recently calculated. N1 is 9 and N2 is 8. So the calculated value we are getting is 3.465252. Right? So therefore calculated T is 3.465252. Table T can be obtained. So see, this is my level of significance is 0.05, and the degrees of freedom in this case is n1 plus n2 minus 2. So n1 is 9 plus 8 minus 2. So this is 15 and 0.05. So if you take this table, if you see this table, so what is the level of significance in this case is 0.05, and T value is 15. So T is 15, and this value is 0.05. So 15 and 0.05 is how much? See, this is 1.753. Yeah, this is the value 1.753. So this I have taken from the table. So what is calculated T? Calculated T is 3 point and table T is 1 point. So calculated T is greater than table T. So therefore we can reject H0. Reject H0 means the mean difference significant to warrant that type 1 is superior to type 2. In our H0, what we are mentioning that type 1 and type 2 are equal. So they are equal. But what we are concluding here, we are rejecting our H0 means the mean difference significant to warrant that type 1 is superior to type 2 regarding length of life. So in the second example, we have given the data set. We have to use the same formula. We have to use the same formula. The level of significance and the degrees of freedom are also the same. So that is the degrees of freedom is n1 plus n2 minus 2 and the level of significance is alpha. So see, find out the observation table. Write down the set 1 values, then set 2 values. So in this case, my n1 is 7. In the first data set, we have given 7 observations, whereas in the second data set, we have given 8 observations. First, calculate sum values and then calculate summation x minus x bar square because that is needed. So again, find out the write down the second observations and take the total and also find out the next column as summation x2 minus x bar 2 square. If you do all these things, what we are getting, x bar 1 is 22. So the value of x bar 1 is 22. See, this is 22. And the value of x bar 2 is 17.625. So this is 17.625. N1 is 7, N2 is 8. So find out this value. So that is sample mean square. So if you apply this formula, what we are getting? So the value we are getting is 12.6056, right? And if you take square root of this value, so the value comes out to be 3.55. So what is the procedure? Procedure is mu1 is equal to mu2 and mu1 which is not equal to mu2. This is two-tailed test. The level of significance is 0.05. So under H0 mu1 equal to mu2. This is the formula and this is the calculated T. This is the table T, right? So calculated T in this case is 2.38. See, this is the value 2.38. And what is table T? Table T can be obtained such that for two-tailed alternative, this is my critical region and this particular value is my table T. And this value is the calculated T. So recently we have calculated this T 2.38, but now we are interested in finding what would be the table T because we need to compare calculated T with table T, right? So table T is 7 plus 8 minus 2. This is 0.05 divided by 2. So this is how much? Table T is 13 and 0.025. So in the table, we have to locate the value 13. So this is the value 13. This is 13 and in this case 0.025. So what is that value? 13 and 0.025. So this value is 2.160. So that is mentioned here. So this is the value 2.160. So calculated T is more than table T. Calculated T is 2.38. Table T is 2.16. So therefore calculated T is greater than table T. We reject H0. So what is rejection of H0 means? The two sets of observations are not drawn from same population. So in this way, we can solve the examples of t-test, whether it is a one sample or it is a two sample. Okay. So please watch these videos very carefully and then understand the procedure and also understand how to find out the values and what would be the test procedure and the conclusion. Thank you very much.